Let's graph the function y equals -4 cosine 3x. So I have a function in the form of y equals a for amplitude, cosine, which is my function, omega x, omega being 3 in this case. And I'm going to start off with my parent function of y equals cosine x. And in order to do that, I like to have a unit circle. So let's make a little circle here. It's a pretty good size. I think I will see if I can't move it over a little bit. Yeah, that's a little better. Okay. And I think I'll put in an x and y axis. This draws it a little bit straighter. X-axis. That's not that straight, is it? Y-axis. I think I can straighten this one out just a tiny bit. That's better. Okay. And so I now have my, I'm going to put my key points around it. So this is the angle 0, 2 pi. This is my angle pi over 2. This is my angle pi. This is my angle 3 pi over 2, and I'll write in my coordinates. My coordinates of this point right here are 1, 0. Up here, my coordinates are 0, 1. Over here, my coordinates are -1, 0. And down here, my coordinates are 0, -1. And as you recall, cosine is the x value of your coordinate on the unit circle. So I'm going to kind of change my points around the unit circle, straighten them out so that they'll be on the graph. So this point right here is 0 degrees, and way over here is 2 pi degrees. So right in the middle of those two is pi degrees, and between 0 and pi is pi over 2 degrees, and right here is 3 pi over 2 degrees. And technically it's not degrees, it's radians, but I'm saying degrees just so that help make it clear that my x-axis here represents the angles, and the y-axis is going to be the value of the function, of the cosine function, at each angle. So at 0, the value of my cosine function is 1. So I will make this a 1 right there. At pi over 2, the value of my cosine function is 0. Well, that's okay. I'll make that 0 right there. You know, I'm going to change ink colors. There's 1, 0. At pi, my cosine is -1. At 3 pi over 2, my cosine is back to 0. And at 2 pi, my cosine is back to 1. So my cosine function looks kind of like this. I'll do my best to graph it. There we go, that piece there. I'm going to make a little bowl this way here, not bad. And then I'll complete it by going like that. So that's my cosine function, kind of a U-shaped function. It may be a little bit exaggerated in the in the edges of the bowl, but you get the picture. So what I'm going to do next is I'm going to transform my cosine function. And for a minute now, I'm gonna ignore the negative sign. I'm gonna get to that before I would do any h or k. We don't even have an h or k in this particular function. I would do the negative sign after I adjust for the amplitude, which is going to be the 4, and the period, which is going to be affected by the omega, which is 3. So first the amplitude. So I could just, since I know that this right here is one, is this point right there is 1, and this point right here is -1. Uh, I could change my dot and bring it way up here to 4, and then down here to -4. Changing my y values, which are 1 and -1, multiplying them by 4. But instead, I think it's easier just to change the axes, because I know that my highest point is going to be 4 and my lowest point is going to be -4. So I'm just going to do this. I'm going to change my 1 into a 4, and I'm going to change my -1 into a -4. So now I've just changed the amplitude of this graph. From now it's not going from 1 to -1, it's going from 4 to -4. The next thing I need to do is adjust the period of the graph. So the period of the graph, the period of the cosine function, is 2 pi. And the way I adjust the period is I go 2 pi, the period of the parent, and I divide it by omega, which is 3. So the period of my transform function is going to be 2 pi over 3. Well, again, I could kind of redraw the graph, but it's much easier just to change the axes. So since I know that the cosine function is going to complete a complete cycle in the period of 2 pi over 3, let's write that down here. 2 pi over 3, well, halfway between 0 and 2 pi over 3 is 1 pi over 3. So this would be pi over 3. Well, halfway between 0 and pi over 3 is pi over 6. And halfway between pi over 3 and 2 pi over 3, well, I think the way I would do that is I would say this is 1 pi over 6, this is 2 pi over 6, this is going to be 3 pi over 6, which is the same thing as pi over 2. I'll write under here, this is 3 pi over 6, you can see. And then this is 4 pi over 6. So these are now the new points on my graph. These points here go away, and they are replaced by these points. So this graph is now fully transformed. I don't have any h to make it go left or right. I don't have any k to make it go up or down. But let's take a look just on the next page to see how this would look if we actually had transformed the graph instead of just transforming the axes. Oh, but wait, I didn't finish. I made a mistake. Because there is, in fact, like it's at the pen here, there is a negative sign here. And the negative sign, just like when we're doing our other transformations that we used to do, means that all of my y values get flipped over the x-axis. So instead of this point being at 4, that point's going to be at -4. This point here at 0, well, flipping over the x-axis is not going to make any change. That point's going to stay at 0. This point, instead of being at -1, is going to be at -4 is going to be at 4. This point here is still going to be at 0. And this point here, instead of being at 4, is going to be at -4. So my fully transformed cosine function now is going to look like this. Sorry for that weird bump, but you can get the picture here. It flipped it upside down. Now let's go to the next page and see if that really works. So I'm going to start out with my I'm going to graph my cosine function. Hopefully it won't change my axes. It didn't. There's my cosine function. And let me so I changed my axes just a little bit so it'll look a little bit more clear. But this is my cosine function. And you can see it starts here at 0. and it heads all the way down to the bottom. It hits its bottom at pi, which is about 3.14. You can kind of see it's 3.14. In fact, I think I can even put some numbers on this. I'll show my numbers. That's a little bit better. And then it goes up, and it finishes off its complete cycle from top to top there at about 6.28, 3.14 times 2, 2 pi. Well, now I'm going to graph the 4 cosine 3x, not with the negative sign yet. Let's see what this one looks like. There we go. Okay. So clearly the amplitude is way increased. I'm starting now at 4, and I'm going all the way down to -4. And my period now is, if you remember, it's 2 pi over 3, which is approximately 2.1. So if I go from peak to peak, you can see it's about 2.1. That completed one cycle. I went all the way down and all the way up. And then I'm going to go all the way down again, and I'm going to go all the way up, about 4.2. And I'm going to go all the way down and all the way up, about 6.3. So we're completing a cycle about every 2.1, which is 2 pi over 3. Now the last thing, just to show you here, I am going to put in the negative sign. And the graph just flipped upside down. I'm starting here at -4. I'm going back up and back down. It completes that first cycle at about 2.1. Up, down, completes the next cycle in another 2.1. So this is what the two graphs look like, changing the graph as opposed to just changing the axes. A lot easier when you're doing it by hand to change the axes, but it is definitely a good idea to know kind of the relationship, what they look like between the actual parent function and the transformed function.